Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department from Ajay Kumar Garg Engineering College. Today we are going to discuss the common bus system using multiplexer and three-state buffer. And the topic is from the subject Computer Organization and Architecture. Before starting the topic, we have to know what is bus. Bus is a communication pathway between two or more hardware components are connected. And the common bus system, actually in the digital system, there are so many registers are there and all the registers are communicating each other. So how all the registers are communicating and how they are transferring the information from one register to another by the common bus system. Suppose that there are n number of registers are there in the system. Then if single wire is connected to the another register, so that if suppose that there are n number of registers, so that n into n minus 1 by 2 wires are required, and it will be very complex structure to implement the hardware. So that's why we are using the common bus system. The common bus system is designed by two methods, that is, first is the using multiplexer and the next is using tri-state buffer. When we are going to create the bus using multiplexer, we have to understand what is multiplexer. Actually, the multiplexer is a combinational circuit which having a multiple inputs and single output. Suppose that there is a multiple inputs as a 2 to the power n data inputs are there, so that the n selection lines will be there in the multiplexer. Why we are using the selection line? We can take one example, that is a typical applications of the multiplexer. Suppose that we want to listen a music from different sources. Suppose we have 3 sources to listen a sound from these. Suppose that we have a MP3 multiplayer or a laptop or a digital, satellite or a cable TV. Out of these, we want to listen a music from only one single device. At that moment, we have a selection line, so that only one multiple input, out of these multiple inputs, only one single input generated the output. That's why we are using the selection line. Now, this is the block diagram of the multiplexer. The size of the multiplexer in general, that is n cross 1. N is the number of inputs and the 1, always there is a single output will be there. And selection line will depend upon how many number of inputs are there. If there is a n number of inputs, so the selection line will be log of base to n. Here is the example for 4 cross 1 multiplexer. If the 4 cross 1 multiplexer, you can see that there is a I0, I1, I2 and I3. These are the 4 inputs and the output is generated by any of these single input. And how these, out of these multiple inputs, how we are selecting that particular output, it is the responsibility of the selection line. Because there are input lines are 4, so that log of base to 2, that log of base to 4, that is selection lines will be 2. So S0 and S1 will be there, or because there is a 2 selection line, so that the combination will be 2 to the power 2, that is 0, 0, 0, 1, 1, 0 and 1, 1. Output will be generated out of any of these multiple inputs. If I want to take the output as an I2, so that we have to select the selection line as a 1, 0. If we want to select the input as a I0, so the output will be as an I0. That is, or we have to select the 0, 0 line will be there. Now, common bus system using multiplexer. By using the multiplexer, that is a combinational circuit, when we are going to create a common bus system, that is useful for transferring the information from one register to another register. We can use a simple example. Suppose that there are number of register value is k and we have to produce the n line common bus. In this particular way, there are number of multiplexer will be the equivalent to the size of the register, and the selection line will be the log of base 2 number of registers. Now, this is the example. This is a summary point that how we are going to design the common bus system using multiplexer. If the number of registers are k and we are going to create a bus with the n-bit common line bus, so that the size of register is n and the number of multiplexer will be n. So that we can conclude it that the size of the register is equivalent to the number of multiplexer when we are going to create the common bus system. And the size of the multiplexer will be k cross 1. 1 is the output for the multiplexer and the k is the number of inputs. Number of selection lines in each multiplexer is log of base 2 k. This is a simple example I have taken, that is a 4-bit common line bus for 2 registers. Here n value is 4 and the k value is 2. So that the number of multiplexer is equivalent to the size of register, so that there is a number of multiplexer will be 4 and the size of the multiplexer is k cross 1, that is 2 cross 1. And because there is a 2 cross 1 size, so that the selection line will be log of base 2, that is 1. Now, first, when we are going to create the common bus system, first of all, we have to create a register. Here, register size is 4-bit. So that we can use that 0, 1, 2, 3 is there. That is the size of the register, and number of multiplexer is equivalent to the size of the register. That's why we are using here as a 4 multiplexers. Now, this 4 multiplexer having the size of 2 cross 1, so that there is a selection line will be only 1, because log of base 2, that is the selection line, and selection line will go each of the multiplexer connected. Now, how we are going to connect the register to multiplexer when we are going to design the common bus system? That moment, the first bit of the first multiplexer goes to first multiplexer. It means that 0th bit of the register, first register, goes to the first multiplexer, or we can conclude the first bit of each register goes to the first multiplexer, and the second bit of the each register goes to the second multiplexer, and the third bit goes to the third multiplexer, and so on. That's we can connected. Here is the direction of the lines is there. This is the direction for the register transferring information from one register to multiplexer and then another register. When this is the 4-bit common line bus using 2 registers. Now, in that particular way, actually we are transferring the information from one register to another register. Here only one selection line is taken place. That's why the value is 0 and 1. In this particular way, when we want to select the output as a register 1, then we have to select the selection line as 0. And when we want to create an output as a n-bit common line bus is register B, then we have to select the selection line as a 1. So that we can conclude that when we want to create the register B transferring information, at that moment the output will be equivalent to the B0, B1, B2 and B3 will be there. Now, this is the another example for bus designing. There is a 4 registers, that is a k value is 4 and n value is again 4. So that there is a 4 multiplexers will be there and 4 registers are there, and the selection line depends upon the input. So that log of base 2 4, that is 2. That's why here the selection line is 2. Now, we can conclude that how the transferring the information in this 4-bit common line bus, when we want to select the register B, at that moment the selection line should be 0, 1. If we want to transferring the information from one register to another register from the register D, so that the selection line will be 1, 1. Here is another example for the 8-bit common line bus with 4 registers. There are 8-bit common line, means n equal to 8 and the k value is 4. Because the k equal to 4, so that the multiplexer size is 4 cross 1 and the selection line will be log of base to 4, that is 2. 2 selection line goes to each multiplexer. And so that we can create the 8-line common bus structure. These are the some advantages of bus multiplexing when we are going to create the common bus system using multiplexer. It is very easy and efficient way for the register transferring information, and the bus multiplexing require fewer wires as we'll discuss. If we are connecting all wires, so that n into n minus 1 by 2 wires required. In this particular way, we are just reducing the number of wires so that the hardware implementation will be easy. Now, the second method to create the common bus system using 3-state buffer, that is, before starting the common bus system using 3-state buffer, we have to know what is 3-state. In the conventional buffer, there is a 2 states, that is a logical 1 and logical 0. In the 3-state buffer, there is a 3 states, means it is also called as a tri-state buffer, that is, first is the logical 1, second is the logical 0, and the third is the high impedance state. In the high impedance state, we have an open circuit. Here is the diagram for the 3-state buffer or a tri-state buffer. The first is a input, normal input, and the second is the control input, and so that the output will be generated. Here the output will be generated when the control signal is 0. Then the output will be as an high impedance state or it is open circuit. Otherwise, the normal input goes and the control signal is 1. At that moment, the value will be, or you can say output y equal to logical 0 or logical 1. In the 3-state buffer, these are the feature for the 3-state buffer, because the logical 1 and logical 0 are the 2 states and the next state is high impedance state. In the high impedance state, output is not connected and the circuit goes like a open circuit and there is no logical significance of the output. These are the differences between the normal buffer or the conventional buffer and tri-state buffer. Normal buffer having 2 inputs, logical 1 and logical 0, and the 3-state buffer having a logical 1, logical 0 and high impedance. High impedance useful so that your complete circuit having no extra loads will be there. When we are going to design the common bus system using 3-state buffer, we have to have some summary points are there. The size of the decoder here, if we are going to create the n-bit common line bus with the help of tri-state buffer, the size of the decoder will be log of base to n into n, and the number of buffers required as n into number of register, where number of register is as a k. The selection line of the decoder will be log of base to n. Now, this is the simple example for the common bus system. When we are going to create the n-bit bus, we need the n circuit with 4 buffers. There are a log of base to n into n, so that there is a decoder is 2 cross 4 decoder. Actually, decoder is a combinational circuit and the size of the decoder is always like n into 2 to the power n, means n is the input and maximum outputs will be 2 to the power n. Here we are using one particular decoder with the size of 2 cross 4 because we are going to connect the 4 buffers. Now, this A, B, C, D is the registers bit which is coming from the different register, that is the register A, register B, register C and register D. And these are actually the A0, B0, C0 and D0. That is the first bit of the registers, and there is the tri-state buffer. The tri-state buffer value, the first input is connected with the first bit of the register and the second input of the tri-state buffer is connected with the decoder 2 cross 4, so that we can create the bus line for the bit 0. This is the diagram only for the bus line for bit 0, so that with the number of selection line is there, if the 0, 0 is going to select, then the A0 will be selected and all other values which is connected with the B0, C0 and D0 is in the high impedance state. Or if you are going to connect with the C value, C0 is there, so that A, B and D value will be in the high impedance state. And this high impedance state is controlled by the enable value. Enable means there is a control signal. When the control signal is 0, then the values goes on in the high impedance state, and when the control signal is 1, then it will treated as a normal output, that is a logical 1 or logical 0. Here is the simple example for tri-state buffer creating with the 4-bit common line bus. If the each register is 4-bit wide, means size of the register of K value is 4 and the number of the register is 4. So, the size of the decoder is log of base to n into n, that is 2 cross 4, and number of 3-state buffer is 4 into 4, that is a 16, and the number of selection line in the decoder is log of base to n, that is 2. This is the first case when we are connecting only first register, that is the 4-bit value. That is 4-bit value means A register having 0, 1, 2, 3. The tri-state buffer, the first input of the tri-state buffer is connected with the register value and the next value is connected with the decoder. Decoder is the size of 2 cross 4 and the enable is the control signal, that is control signal can be 0 or 1. If the control signal is 0, then it goes to the high impedance state, otherwise it gives the normal output. Now in the second register again connected with the 4 tri-state buffer, that is 0, 1, 2, 3 bits, or you can say there is a B0, B1, B2 and B3 is connected with the 4 tri-state buffer, and the tri-state buffer second input goes to the 1th line of the decoder. The same procedure will goes on, that is the third register will connected with the tri-state buffers and next value will be connected with the decoder. Now in this particular example, we can show that there is in the decoder there is a 2 selection line because log of base to k, that is a S1 and S0, 2 selection lines will be there, and when the selection line is 0, 0, then only A register produces the output, or a 4-bit common line bus produces an output as a A0, A1, A2 and A3, and other B, C, D will be in the high impedance state. When transferring the information from C, then at that moment selection line will be selected as 1, 0 and other A, B, D register will be is in the high impedance state. Thank you so much.